speaker this morning is Michael Barany from the University of Edinburgh, who is going to give us a talk on situating modern mathematics. Over to you.
Thank you, Deborah, and thank you everyone for holding off on lunch for another hour while I talk to you a little bit about a project that we're almost halfway through now, about the globalization of modern mathematics and some of the methodological and conceptual and indeed sometimes, although I hesitate to admit it, philosophical problems that come with trying to understand the changing scales of modern mathematics. Scale and modern mathematics are, of course, themes that we've talked a lot about this entire semester. We've already talked about it a little bit this week. There are people in this room who have written articles and books on this topic. So we have a lot of ways into this question and a lot of approaches and a lot of challenges that are well, I would say, well established. So what I'm going to try to do with this talk, and I hopefully will also have left a lot of time for discussion at the end, is to raise some of the challenges and approaches that I see as, if not necessarily distinguishing, then at least significant and potentially distinctive for the approach that I'm taking, that my research group is taking, to this challenge of understanding the significance and the dynamics and the consequences of changing scales of modern mathematics. And the starting point, and I don't think this is emphasized enough in the literature on modern mathematics, my starting point for this research is the observation that mathematics is difficult, maths are hard. And the reason I think this is an underemphasized starting point is because historians of mathematics tend to go into an archive, into a historical text, with a goal of understanding what it says. Right, so this is obviously something we all have experience with. It's one of the taken for granted premises of the field, is how we identify our research problems, is how we connect ideas together. And it's also something that our historical subjects do. When our historical subjects encounter a mathematical text, their main object is to produce a mathematical understanding of that text. Indeed, ideally, to produce that kind of understanding in a way that allows them to produce new mathematics, to produce different mathematics, to share that mathematics in a clarifying or insightful or useful way. And I think as historians of mathematics, and particularly as historians of modern and contemporary mathematics, it's very important to pay fundamental attention to the persistence of the hardness of mathematics across these efforts at creating understanding. And by this I mean we need to look not just at the processes of generating comprehension, of generating new insights, but also the massive difficulties that inhere in the process of seeing mathematics as understandable, of after seeing mathematics as understandable, then attempting to understand it, after forming some kind of understanding, then trying to share that understanding with someone else. After sharing that understanding with someone else, then trying to make that understanding mobile in a way that can be shared with someone that you're not directly interacting with. These are all different layers of the difficulty of mathematics that whose ramifications, whose instantiations, whose contextualizations, whose implications, I think help us identify what is distinctive and what is distinctively challenging historiographically about modern and contemporary mathematics. So to spell out a few of these things that I just indicated, we're interested in how mathematics is hard to conceptualize. You'll have lots and lots of illustrations and discussions this week about the historical conceptualization of mathematics. So that's not something that I'm going to dwell a whole lot about, but I think one thing that we can do more of is connect these other forms of the hardness of mathematics to the hardness of forming mathematical concepts in the first place. Mathematics is very hard to communicate. Mathematics is very hard to understand. And under understanding, we're all familiar with the difficulties of teaching mathematics, of learning mathematics. So we're talking about not just about a sort of formal research context, the kind of understanding that happens in a building like this, but also the kind of understanding that happens in the building on the other end of the green, in more explicitly pedagogical, didactic contexts. And there is indeed, as people in this room are more expert than I am, a very fundamental and long-running relationship between the didactics of mathematics and mathematics as a subject or object of research. So there's understanding, but then also, and we saw a brilliant illustration of this in Sasha's talk at the start of the day, there's the problem of agreeing about mathematics. And this is a problem that is in many ways separate, but obviously very connected to the problem of understanding. So you can have, you have the challenge of convincing yourself that you're talking about the same thing, convincing yourself that your understanding about that same thing corresponds, but then you have to have the additional problem of validating, of forming a common understanding that what is common about the way of conceptualizing a mathematical object or process or claim is indeed correct, consensual, shared, and that's a different level of hardness. And there are also problems in evaluating mathematics, and these I think are not often lumped in with the historiography of mathematical concepts and conceptualizations as such, but when you're looking at things like what makes a mathematical career possible, what goes into the awarding of a mathematical prize or distinction, how does mathematical funding get allocated, how does a problem get identified as important, and we saw some good examples of this in Jesper's talk that I'll just call back to show that I think we all have a sense that the challenges of evaluating the importance or the significance or the value of mathematics and mathematicians has a really deep-running hardness that has a fundamental implication for what mathematics has done, how mathematics is understood, what mathematics means in its historical context. So that's our starting point. Maths are hard. I try where I can. I mean, I'm going to be a bit sloppy about this, but I try to pluralize mathematics where I can. In part, this is just poking fun at Bourbaki, who's one of my main historical actors, who does the opposite move of really obnoxiously trying to singularize mathematics whenever they can. But I think, yeah, so I'll just sort of kind of blend our UK and American habits here and try to pluralize mathematics where possible. One of the methodological implications, I think the most important methodological implication of the hardness of mathematics for the program of research I've been developing over a longer period, including before the start of the Sigma project that I'll be telling you more about, is the idea that the way to understand mathematics in the modern and contemporary period, both conceptually as well as institutionally, as well as infrastructurally, is to look at mathematics in terms of, here's the key phrase, relationships of partial, mutual understanding. So each of these words is important. Relationships is about the relationality of mathematics as a field, as a form of knowledge. So the problem of scale and difficulty in mathematics is a problem that emerges most significantly, most meaningfully, and also most attractively to a historian at the level of interpersonal and intercommunal relationships. And there are relationships that are oriented around specific kinds of challenges of understanding. They're challenges of understanding that are directed at producing a kind of mutuality, a form of shared community, a form of actionable allegiance or commonality. And these mutual understandings around which these relationships are oriented are always partial in at least two senses. So the sense of partial as fractional, that there is no such thing in mathematics, I mean in knowledge in general, but we're interested in mathematics in this room, in a complete or totalizing or final understanding. That's sort of a premise of the approach to the history of knowledge that I start with, but also I think is very amply demonstrated in the archives. So partial in the sense of incomplete, but also partial in the sense of favoring or biased or reflecting a particular perspective or inclination. And to recognize that the understandings that people bring to historical mathematics are always and invariably and consequentially inflected by the perspectives, the values, the priorities of the people expressing, communicating, interacting around that mathematics is both analytically but also methodologically essential. The Sigma project, which, so for those who have had the misfortune of having to apply for European funding, there's sort of an expectation that, that you come up with an acronym that makes it fundable. So the Sigma project is situating international and global mathematics. The Sigma project is an attempt to take this methodological starting point and ask what it tells us about a kind of sequence of significant scales in modern and contemporary mathematics. Those are the scales of international, intercontinental, and global mathematics. I am not the only one, even within a 5-meter radius, who has attempted to define global mathematics in the recent past. But I think that the reason I think it's important to think about it in terms of this this sequence is that there has historically been a very strong conflation between international ideals and international initiatives and a kind of global project of mathematical interconnection. And I think historiographically, it's essential to distinguish these different scales as involving different institutional forms, different infrastructural requirements and prerogatives, and also different kinds of mathematics and different kinds of mathematical people and mathematical processes and practices. So we're probably in this room most familiar with the international scale of mathematics, that is, mathematics conceived of both in terms of national organizations and societies and institutions and projects, and also connections between those national scales and forms of mathematics. In my, it feels kind of grandiose to call it earlier work, but in the work that came out of my PhD project and my early postdoctoral work, I tried to articulate a difference between international and intercontinental mathematics as seeing connections between mathematicians on different continents as involving different kinds of organizational decisions and priorities, as well as different sources of different funders, different forms of evaluation, as well as different practices of creating mutual understanding. So, and in contrast to international mathematics, where there's a heavy reliance on the nascent 19th century system of international publication in European languages, where there's a strong emphasis on forms of travel and contact that are mediated by technologies such as trains and boats. There's postal correspondence. There are just different kinds of activities and technologies and assumptions that go into mathematical connections and communities when the goal is crossing an ocean rather than, or a very large sea or a very large range of mountains, as opposed to crossing what was typically in the sort of model international exchange, a border within Europe. And then I think there is, again, a change in scale that we need to consider, one that doesn't make a sharp historical break, but represents a different kind of genre of analysis and a different genre of historiographical problem in thinking about the global scale of mathematics as one that invokes a kind of imagination of mathematics as somehow significantly, but also in a differentiated manner, accessible, meaningful, not just in a scale that connects continents, but in a scale that somehow erases the salience of continental differences in a way that, of course, reinforces and relies on other forms of differences, but where the aspect of intercourse between continents becomes less salient. And so you can think of the distinction between, say, 1930s, 1940s, and 1950s connections between North and South American mathematics, which are driven by a particular constellation of philanthropic priorities of the Guggenheim and Rockefeller Foundations, of governmental priorities of the United States State Department, the successive governments of Argentina, Brazil, and Uruguay. You can think of the difference between those kinds of projects and exchanges and the later formations that would, for instance, be driven by the strong mathematical connections between the Institute for Pure and Applied Mathematics in Rio de Janeiro and the Institute for Institut des Hautes Études Scientifiques in Paris, as reflecting a different kind of configuration of funding and priorities and training infrastructures and communications infrastructures. So I think that's the genre of difference that we're concerned with here. And the claim is that these last two scales, but particularly the third of these, and I'm almost out of board space, but I'm going to put 3 more words here, that these are recent, contingent, and precarious. Contingent is not a word I usually have to explain to historians. Neither is recent, but recent in particular, I want to say that the intercontinental and global scales of mathematics are even recent relative to comparable sciences. So if you compare the institutional career research formations of mathematicians to, say, cosmologists or high-energy physicists or chemists or botanists, mathematicians develop these kinds of scales and institutions and infrastructures much later, and the lateness of that is not just sociologically but epistemically significant. And I think this term precarious I'm going to get to a bit more at the end of the talk, but I think one of the most important implications, and this is, I think, something that the organizers of this semester have made very clear, that we're interested in not just in the implications of our work for historians, but also for mathematicians. I think one of the most important implications of this work for mathematicians is to underscore the extent to which current configurations of mathematics and current aspirations to global reach and global significance for mathematical research in particular rest on assumptions and infrastructures that are far more precarious than is usually assumed and may require different kinds of institutional forms, different kinds of methods of evaluation and reconciliation than are currently taken for granted by mathematicians. So that's our framing of the question. I've taken a long time explaining that just to spell out where we're going and what's significant about it. I want to illustrate what this looks like methodologically by talking about 2 examples of what I've come to start calling in my research a kind of methodology of kaleidoscopic itinerary. So let me write that out. The kaleidoscope is a technology of, it's a philosophical instrument, is the term, the early 19th century term, emerging out of David Brewster's experiments in scientific optics. It's a device for probably most people here are familiar with kaleidoscopes. It's a device for using mirrors and some kind of starting image to create a pattern, to create a highly symmetric pattern that Brewster thought could be inspirational to artists and engineers and philosophers, help them see things in new ways by appreciating the way that symmetry can disrupt or augment our limitations of visual perspective. And I think this technology, but also the idea behind the technology, is a useful way of thinking about a way of disrupting our historiographical perspective on the history of the kinds of difficulties and relationships of modern and contemporary mathematics. And I also have a kind of personal interest in reclaiming David Brewster a bit as someone who is currently employed by the University of Edinburgh. Brewster was at the end of his life the first modern lay principal of the university. He took this office after a major legal reform of universities in Scotland, enacted in 1858. That's a piece of legislation to which I've had to refer many a time in recent years in my capacity as an academic senator at the university, and it's a historical context that I think many in my university would do better to be more aware of, including some members of our senior leadership team. So the kaleidoscope has this context in the history of universities, in the history of optical technologies, in the history of conceptions of the imagination. And in the context of this research program, what a kaleidoscopic approach to the archives has let me and my team start to do is insist on the combined, situated, and perspectival nature of our historical sources, of our ways of understanding the difficulties and relationships of modern and contemporary mathematics. I'll illustrate this by talking about two mathematicians from what is often called the Global South, who have stood out from an early stage as important in my own archival investigations. One of these is José Luis Massera, a mathematician based in Montevideo, Uruguay for most of his career. Massera's sort of entry into intercontinental mathematics came in the 1940s when he was identified by an Uruguayan physicist, Walter S. Hill, to his contact in the Rockefeller Foundation, Harry Milton Miller, as the most promising young Uruguayan mathematician. Having piqued Miller's interest, the Rockefeller Foundation then undertook what ended up being an extended series of negotiations and discussions and challenges to enable Massera to spend what ended up being about a year and a half in the United States, first in California, then in New Jersey and New York, and then returning to Uruguay by way of Texas and Mexico. Massera ends up spending most of the rest of his life and career in Uruguay, but there's a lasting significance to the connections and relationships and challenges he encounters in this short trip to North America. And in particular, this trip generated a tremendous variety of different kinds of sources of evidence that speak to different aspects and perspectives on Massera's itinerary and his work. So before laying those out, I'll introduce the other character who I followed in somewhat similar and somewhat different terms to Massera, and that's Damodar D. Kosambi. Kosambi spends most of his childhood in Cambridge, Massachusetts. His father is a Sanskritist who's employed on a contingent basis at Harvard, teaching Sanskrit language and associated cultural and religious studies. Kosambi shows early promise in mathematics, and as a result, meets many of the people who would become the most influential modernizers of mathematics out of both Harvard and MIT, figures like Marshall Stone, Norbert Wiener, end up having a very large influence on Kosambi. He attends Harvard for his degree, and then his family return to India on the basis of Kosambi's distinguished academic pedigree and training, and his inventiveness in his record as an emerging mathematician. After a short appointment in Aligarh in north central India, he is invited to become, in a slightly longer stint in Pune, which is closer to his hometown, near just a little bit outside of Mumbai. He's invited to become the founding head of the mathematics department of the Tata Institute of Fundamental Research, and develops a contentious and internationally oriented career and body of work, not just in mathematics, but he ends up becoming quite influential in historiography and in mathematical historiography in particular. Not the historiography of mathematics, but in the use of mathematical methods in the history of primarily numismatics, but a number of other fields of ancient history. And he becomes quite recognized as a former of the modern Marxist historiography of ancient India. Kosambi and Massera are both quite active in Marxist politics, but from very different perspectives. Massera is active within the party apparatus in Uruguay. He's the Secretary General of the Uruguayan Communist Party in a way that lands him in prison for a number of years and makes him a cause célèbre among mathematicians and others in the 1980s. Kosambi is never quite aligned with party politics, but is very active in international Marxist peace movements and cultural projects of cultural and intellectual solidarity. How to understand these two figures? There's, of course, a sort of a conventional way of going about the historiography, the historical understanding of figures in the modern and contemporary period, figures who have quite large bodies of publication, who have extensive networks of correspondence. You look at what they've written, you look at what they've published, you look at where they've been, and you develop a kind of story of a conceptual, intellectual trajectory that embraces in many ways the kinds of deracination that these figures would have necessarily embraced as part of their own careers. That is, the process of forming a mathematical career in the modern contemporary period is a process of promulgating a persona and a body of conceptual, theoretical, technical work that links to other locations, that is aimed at transcending the particularities of your own context of study or research or interaction, and doing this through apparatuses such as the mathematical literature, through certain kinds of correspondence and communication and personal projection. What I want to do with this method of kaleidoscopic itinerary is to try to invert and relocalize the activities of these two careers by finding multiple sources that speak in different ways to the same pivotal events from their lives and careers. And the source that links them in, I think, quite fruitful and provocative ways is the United States Federal Bureau of Investigation. So we talked about all the way back in January during one of the early seminars of the Veblen program from the MHM series of programs about the sometimes surprising fruitfulness and also difficulty of both obtaining and then working with the case files of the U.S. Federal Bureau of Investigation. This is a source of massive paper trails in the 20th and indeed the 21st century. In mathematics, 21st century files are much harder to obtain for obvious reasons. But for the period that most interests me about Massera and Kosambi, it is, at least in principle, if you're willing to be persistent and wait a very long time, possible to get a view of the kinds of records and notes considered salient by the field officers and the headquarters officers of this particular bureau. And what the FBI is interested in is, of course, not the theories of differential equations or probabilistic mechanics of these mathematicians, but the connections between their travels and their politics and their interpersonal relationships. So the FBI file in this circumstance is a way of recentering the salience of cultural connections and political priorities in the careers of these two mathematicians. And one does so by connecting what's in the FBI file with other sorts of sources. So in Massera's case, there's an extensive run of correspondence of letters that Massera wrote to his family members during his trip to North America. I've accessed 2 copies of this correspondence. One copy in the Archivo Privado of Massera, the personal archive at the University of the Republic in Montevideo. The other copy is much harder to read because it's in microphotography held by the FBI, who intercepted all of his mail on its way to Uruguay. And you can see in the contrast between how these documents mattered to, in the first instance, Massera's family and the FBI agents who were worried about him expropriating nuclear secrets to the communist world. A different set of values and priorities and ways of understanding and evaluating mathematical itineraries and mathematical interests and careers. So you have a sort of contrast between the personal archive on the one hand, a very emphatically non-mathematically interested archive, but there's also a sort of range of archives that bridge those sorts of interests. One of the most important midpoints, let's say, between the political, cultural archive and the personal archive is the archive of the Rockefeller Foundation, the funder of Massera's travels. And in particular, the notes of Harry Milton Miller, who's the officer who handles Massera's fellowship. And the contrast between Miller, who's also not a mathematician, his notes, and the FBI case officer's notes is absolutely striking, because both of them are trying to understand Massera's travels. Miller with the goal of facilitating, the FBI with the goal of sort of mitigating or managing or averting risk. And both Miller and the unnamed FBI agents are very concerned with who Massera is meeting, why he's meeting them, where he's going on his days off, how he's funding his trips. But they're interested in from vastly different perspectives. So Miller is concerned with how Massera is establishing the basis for an internationally connected scientific career when he returns to Uruguay. The FBI agent is concerned with the potential for spreading communist propaganda and expropriating nuclear secrets. They're both quite oblivious to the details of Massera's mathematical program. They're completely unaware in a way that comes out in other ways in Massera's correspondence that his mathematical trip is not going very well, is not making the kinds of connections or research understandings that he was aspiring to. And instead, they show the sort of the differential significance of those different the different other connections that matter in the sort of broader contextual scheme for Massera's work. Within the archives at the University of the Republic, on the other side of this sort of dynamic is the personal papers of Massera's colleague, Rafael LaGuardia, who is the one Rockefeller Fellow in mathematics prior to Massera to go to North America, has a much more, in his view, successful Rockefeller trip and stays much more connected to the formal organs of international mathematics in the 1950s and onward. And LaGuardia represents, from the converse perspective of someone very much interested in Massera's mathematics, the same kinds of institutional concerns that were promulgated by Miller. So a concern with how Massera is going to make and sustain a career in a politically volatile and also sort of financially volatile context of the emerging university system and technical education infrastructure of Uruguay, but finding different kinds of significance in the connections that are formed there. We also have connections evident in this archive between Massera and American mathematicians like John Robert Klein, the longtime secretary of the American Mathematical Society, someone we also heard about in the talks in the January program from here. Someone whose main concern about Massera is whether the political difficulties that are engendered by the interest the FBI has taken in him are going to end up causing problems for the potential for including Uruguayan mathematicians in Klein's international projects, principally the 1950 International Congress of Mathematicians. Massera is very connected to another figure who becomes a mutual point of contact for these two, Marshall Stone, the founding president of the post-war International Mathematical Union, For Stone, Massera is a kind of cause célèbre. He's someone whose brilliance in mathematics was obviously and unequivocally thwarted by the political insensitivity and prejudice of the countries that would play host to him, particularly when it came to Massera's potential travels to the United States. One other name that should be on here is Solomon Lefschetz, who's responsible for connecting Massera to the mathematical community, the topological community in Mexico, is also someone who keeps Massera integrated into the reviewing architecture and infrastructure of modern mathematics by referring Russian language articles to Massera, Russian being a language that Massera learned in order to keep in touch with his Soviet political context, but it ends up being helpful for his ability to create mathematical connections as well. And these kinds of multiple interactions allow us to tell a story that decenters certain conceptual or even immediate career or publication-related priorities of Massera, and tell another kind of story about how he ends up becoming, for many different people and from many different perspectives, a nexus of concerns about the relationship between mathematics, travel, funding, politics, publication, and other concerns. To take the story over just very briefly to Kosambi in the interest of time, we can tell a similar kind of story about the relationship between the FBI file and other sources for Kosambi. In particular, his personnel file at the Tata Institute for Fundamental Research. Kosambi shows up in the FBI's files indirectly through the file of Marshall Stone. He shows up in Stone's file because Stone has applied for security clearance, has had the security clearance granted, but wants to make sure he can retain the security clearance. And so he presents himself at the FBI headquarters in Washington, D.C., and demands an interview. The FBI doesn't know what to make of this because no one in this period generally volunteers themselves for more sort of exposure to accusations of communist sympathies. But Stone says, just so you know, I've got the security clearance. I'm also in mathematical contact through my international organizing activities with Damodar Kosambi, someone who is of a sufficient profile to have been on the 1950 Fields Medal Committee. And he wants the FBI to know that although Kosambi is a Marxist, and although, and this is a quotation, all Indians are a bit strange, they shouldn't have any concerns because Stone's relationship with Kosambi is strictly professional and mathematical. The FBI takes this interview as an opportunity to review their notes on Kosambi and to indeed confirm that he's considered and known to the FBI as a radical Marxist and someone of political concern. But Stone's preemptive measure allows him to avoid political consequences for his mathematical interest in, and I should say mathematical in the broadest sense, because Stone is not at all interested in Kosambi's literal theorems and calculations, but interested in his role as a mathematical institutional connector for the basis of post-war mathematical internationalism. So you compare those files with the files of the Tata Institute, which are also very much concerned with Damodar Kosambi's potential to be a connector between mathematical institutions and mathematical organizations, but from a perspective of a kind of power struggle within the TIFR of what form of internationalism and what kinds of international connections to favor. This is a power struggle that comes to a head when an increasingly diffident Kosambi starts promoting claims to have proven major theorems. By the end of the 1950s, the Riemann hypothesis is the one he sticks to most ardently. And this set of mathematical claims is transparent in the TIFR archives, as well as in the personal archives of Kosambi, which are at it's been renamed since then. When I visited, it was the Nehru Memorial Museum and Library. It's been renamed at least once since I visited there. Where you see a set of mathematical claims in particular about having proven the Riemann hypothesis, are best evaluated not strictly in terms of their mathematical content or conceptual content, but in terms of their role as set pieces in this power struggle over the form of internationalism and intercontinentalism within the TIFR and also within the broader Indian pure mathematical research community. The DDK archive is also usefully contrasted with the archives of UNESCO. Kosambi's only real international travel after returning to India from Cambridge is a shorter trip to the Institute for Advanced Study in Princeton, as well as the University of Chicago, funded by UNESCO with the goal of laying the groundwork for a UNESCO computing initiative to be based at the TIFR. And in between these, you get a series of correspondence with a range of American mathematicians. Andre Weil, Kosambi's close correspondent and friend, and sometimes frenemy from the 1930s, from the early stages of both of their careers. Paul Erdős, someone who very sympathetically reads and corresponds with Kosambi's increasingly aggravated number theoretical pleas for comment and insight on his Riemann proof. Norbert Wiener, who builds on this earlier contact into an extended set of correspondence about the potential and the fruitfulness, but also the difficulties of Kosambi's combined sort of political and mathematical condition in India. And the upshot of these connections is a story where the research priorities, the means of communicating, the means of institutionalizing are embedded in this, I think, quite usefully kaleidoscopic range of sources and perspectives that help us get a different understanding of what it is that matters from the difficulties of Kosambi's or Macera's careers, mathematics, projects of agreement and reconciliation in their respective periods. Looking outward from this, the Sigma project is broken down into three sort of general clusters of work that I've already kind of sketched out for you. Institutions, word with too many T's. So institutions, infrastructures, and implications. Again, alliteration is a European Research Council application requirement. And within each of these streams, what we've been trying to do is understand the commingling of different kinds of concerns and conditions and contexts for mathematical research in these periods of interest. So I will do a lot less annotating now in the interest of time, but under institutions, what we've identified as important areas for research are understanding the formation and the interconnection of national and international and transnational societies and organizations. We're looking at the different kinds of roles and functions of institutions of research, be they academic institutions, dedicated research centers like the INI, and its many important mid-century precursors, the ecosystems of funding and research and travel and training that make up the possibility of modern mathematical careers. We're looking at the institutional context of mathematics as a project of nation building, of class formation and class reproduction, mathematics as a form of cultural exhibit, as a cultural lever, particularly in the developing world, but also, for instance, in context of post-World War II reconstruction in the North Atlantic, where investment and funding of mathematical research is explicitly promoted as a project of cultural refiguration and reconstruction. One term I will put on here is the role of mathematical personae as a lens of analysis. So I have an edited volume of a few years ago about the history of scholarly personae, where there and elsewhere I've tried to make the argument that an institutional perspective on the formation and propagation of particular sort of modes of being a mathematician are an important way to understand what is distinctive about modern and contemporary mathematics, and something that helps us link the institutional conditions of mathematical research to the infrastructural conditions and the cultural conditions, as well as the intellectual projects of mathematical workers. And I think Bourbaki is, again, one of my sort of recurring examples of the importance of persona construction as an element of mathematical work. Under infrastructures, I'm just going to do a little 2x2 diagram to explain our focus. So we're interested primarily in two acts, sorting and finding. And we're interested in two objects of sorting and finding, people and texts. And within each of these, there are a number of things that we focus on. So on sort of this part of the quadrant, we're interested in things like mathematical careers, mathematical funding, mathematical awards. Directories of mathematicians fall somewhere around here in this quadrant, or in this diagram. Correspondence networks fall a bit over here. You heard in March from my fabulous postdoc, JP, about supply as an issue within mathematics, which is fundamentally around the question of the finding and production of mathematical texts. Abstracting as a practice that connects these different kinds of elements of people and text through the challenges of sorting and finding. The journal system and its evolving role in mathematics sort of sits sort of between people and texts on the sorting side of this diagram, and hopefully you've had a chance to interact with my other fabulous postdoc, Jan Berhovsky, who's working in particular about the longer history of classification in modern mathematics as a way of understanding the infrastructural problem of sorting text and the way it ends up ramifying around challenges of finding and sorting people and text, as well as creating different kinds of institutional formations. The implication side of this is where I'm going to return in 2 minutes' time by way of conclusion, but this is the point, and then it's something we can elaborate on over lunch and later on in this week, where I think the implications of this sort of, especially this precarious aspect of the global scale of mathematics, end up becoming quite salient. So looking at the changing conditions in contemporary funding and careers and mobility, concerns about diversity and justice, and sustainability of mathematical research. These are the kinds of questions that I think benefit from being tied into new understandings that we're attempting to produce around the institutional and infrastructural dimensions of mathematics. I'm going to raise like 3 or 4 theoretical words, and then I'm going to conclude. So how are we understanding these from the basis of this starting point that we've established? One concern that we're bringing to this is the problem of local homeomorphism. So probably I don't need to define this in terms of differential geometry in this room, but in terms of historiography, local homeomorphism is the problem of how mathematicians, when they travel or make other forms of connections, how do they make a recognizable surrounding for themselves that allows them to produce mutual understandings and mutual agreement and mutual evaluations of mathematics. So things like the presence of blackboards in research institutions in different parts of the world, and how those are homogenized through different customs and expectations of maintenance and access and supply. The problem of creating mathematical libraries that support interconnected mathematical research, so that a mathematician can travel from Brussels to Cairo and feel that he's still able to do mathematical research, which is a concern that comes up very strongly in the UNESCO archives. We see problems of translation as a major focus. And this is translation not just of languages, but of institutional forms, of infrastructures, of practices, of cultural contexts. And I'll just refer you to writing I've done, in particular, 2 theoretical terms I found useful, borrowed from the cultural studies of language and translation, is the distinction between homolingual and heterolingual frameworks for understanding linguistic difference. So one thing that's very important in the sort of theoretical imagination of certain kinds of globalizers of mathematics is the idea that all mathematics is in principle universal and translatable. And you see a very big difference in across, for instance, these kaleidoscopic approaches to the archives between people who believe and take that kind of fundamental translatability and universality as a premise, and people who take an opposite view, who fundamentally see the work about creating good enough working combinations and contexts and connections. And that sort of distinction has been very useful in the research. We had a meeting 2 weeks ago, so I'm not going to recapitulate here. a set of related concerns about the different kinds of figurations of centers and peripheries. In mathematics, and the way that different forms of institutional and infrastructural connection can have kind of unexpected connections or unexpected implications for the structure of mathematical research and mathematical communities. So I thought I would just, I guess I got 45 seconds? I've got 45 seconds. We're going into the lunch break, so I can, people can talk to me during lunch. I just want to end by explaining the title of the talk. The titles are like jokes. You shouldn't really explain them unless you think that maybe it hasn't come through. So the title of the talk, Situating Modern Mathematics. And the idea of situating modern mathematics is to sort of play on the multiplicity of situating. So situating in terms of finding the location, identifying the situation, but also situating in the sense of putting in its place. So I think one important implication of this research is to provide a kind of context for understanding the limits and the inadequacies of certain kinds of assumptions and forms of modern and contemporary mathematics as a kind of critical resource and critical apparatus to not just support or promote, but challenge and reimagine certain taken for granted forms of mathematics in the contemporary world. And I think it's this kind of critical potential and it's the recognition of the role of situatedness not just as an explanatory tool, but as a source of imperatives for modern and contemporary mathematics that speaks to the significance of this kind of research. So I will end there.
Thank you. Do we have questions for Mike?
Just one very simple, just how, when you say modern mathematics,
Yeah.
Is there any chronological attachments to that, or religion or period?
Yeah, that's a wonderful question. Question is, how does one delimit modern mathematics? So, I think that's an important question in particular because defining modern mathematics is something that the mathematicians we're interested in are also trying to do. So, in particular, I use the term as a way of signaling an interest in the sort of early to mid 20th century mathematicians who are explicitly taking and attempting to define and make use of this term as a resource for their institutional and cultural and political organization and connection. So it's a term that doesn't have a fixed chronology or a fixed location, but that you actually have to follow and identify in the different places where it becomes mobilized. And the idea that, for instance, and one thing we were talking about just outside, like in the University of Ibadan, when it's being set up after World War II, the idea of creating a connection into modern mathematics had this very specific geopolitical significance that that I think has to be understood as a situated artifact and a situated formation in a way that makes it very different in Ibadan in 1949 than it is, say, in Rio de Janeiro in 1953, than it is in Mumbai in 1957. And that kind of connection, I think, is really important for the project. So that's not a direct answer to your question at all, but it's if that's a question that you're really interested in, may I invite you and everyone here to go to our website and look up the BRICS, BRICS project, which is a series of discussions that we started here a couple weeks ago, and we'll be continuing online over the month of May and a little bit into June about mathematics in Brazil, Russia, India, China, and South Africa, but as an invitation to think about the problems of the geopolitics and scale and connections of mathematical modernity in a way that is a little bit different to the some of the more common ways of thinking about how to define and where to locate modern mathematics. So I'm sorry again for abusing your question to make a different point, but that's something I hope you will consider.
Question. Okay, go ahead.
So I was just wondering, so you're looking at modern mathematics, would this whole kind of framework would there be parallels for, say, modern physics and modern chemistry and What is it? Is it the intellectual character of mathematics that really makes it special, or is it a wider framework?
So I think what's striking about the comparison between mathematics, physics, chemistry, astronomy in these periods is mathematicians are often looking to their colleagues in those other sciences and being kind of surprised at how far behind they are in terms of their international and global and related ambitions, because they go into their work with the assumption that mathematics is supremely portable, that it doesn't have major infrastructural requirements, that it's much more translatable linguistically and otherwise. And this is why I keep coming back to the hardness of mathematics as a research premise, because they're constantly finding that, in fact, the mathematics isn't moving in the way they expect it, is not able to be a basis for international solidarity or transcontinental solidarity in the way they expect it to be. And so when mathematicians are looking to their colleagues, it's often to say, like, why don't we have that yet? Or like, what can we learn from the way that astrophysicists have been internationalizing, and wondering why they sort of haven't gotten there yet. And not really appreciating the nature of that difference, or sort of grappling with the nature of that difference in a way that I think is quite striking. But yeah, I think by and large, and this is what also historiographically I have to draw very much on, is there are excellent histories of like IUPAC for the chemists, and the corresponding organizations for physicists and astronomers. Those histories are an excellent historiographical foundation, both for how they show some of the conditions for like international diplomacy in science, and how that gets connected to the priorities of different scientific communities, but also for the extent to which those stories don't translate into mathematics, I think in quite significant ways.
Just picking up on something you literally just said.
Nice.
When you said the actors that you're looking at, they were, I don't know, disappointed or whatever about how much international solidarity maths had built. Is there subtext there that those actors are American? Or, like, and my question builds more on, as someone who's worked a lot on women in maths, it's really hard to step away from everything centering men and to not still accidentally center men. And I'm just wondering, like, from your talk, I know you're aware of this, and just how much of that is a problem of not accidentally centering America in like the 19th.
Yeah, so I think it's not just Americans who are seeing this and being sort of confused and disappointed. And that's one of the reasons it's important to get. So a lot of people who have written about, so for instance, like I learn a lot, I draw a lot from Karen Parshall's work on this sort of North American, South American connection. One of the things that I think one way I sort of build on that is by deliberately trying to say what views of those itineraries and travels and connections do you get by trying to get as far away from the American archives as you can, and get not just non-American perspectives on the non-American actors, but also the non-American perspectives on the American actors, and try to provincialize them in that way. So that's really important as a way of disrupting some of our assumptions about the way money and power and politics matter to these mathematicians and to these institutions. Your question wasn't about like where the women in the story, but I think that's also an important. I mean, that's kind of the premise.
I'll also ask that question.
Yeah.
Where are the women?
Yeah, they're in a lot of interesting places. But so I think it's tricky because of the way that mathematics in particular has been situated institutionally in a way that creates these protected spaces for male labor and male solidarity and male homosociality. And so one aspect of this project is trying to identify the effects of the production of male spaces for mathematics as an insight into sort of the gender dimensions of the kinds of formations that come up here. And then try to find from there how women enter the story in sometimes expected ways and sometimes unexpected ways. So the way that women family members show up in UNESCO grants as often scientists in their own right who are making productive scientific travels on the basis of grants given to mathematician husbands, and the way that sort of the assumption that a male mathematician will travel with his family ends up affecting women's mobility in mathematics between continents in this kind of backward way. But then the other place we really looked very strongly is at the infrastructural scale. A lot of the people doing the sorting and finding of texts and people in mathematics who are not directly engaged in making mathematical theorems themselves are women who have mathematical talents and mathematical interests who are, due to structural exclusions, unable to make careers in mathematics, but they make careers in mathematical organizations and mathematical publishing houses. There was, again, calling back to January, Sloan was talking about Caroline Seeley as an example. In the American Mathematical Society, Gwen Blake is someone at the Institute for Advanced Study in Princeton who I'm really interested in as also sort of occupying this role, but from a less mathematical background. But there are lots of these examples of women forming, of institutional and infrastructural foci as being a way to find the work of women in this discipline that has had the effect of really strongly centering male careers and male personae. So that's the other, again, hijacked version of your question.
All right, let's thank Michael again.